Alright, so this lesson is 7.6 common logarithms. So a base 10 logarithm, okay, is called a common log. Okay, it's commonly written without its base. So we have log base 10 of x, usually just written log of x. So if you have a graphing calculator or scientific calculator, you'll see that it says log. Alright, so wherever there's a log on the calculator, that is a base 10 or common log. Alright, so a couple quick little ones to start off here. If we were in class, it'd be easier to do. But so to evaluate a logarithm, you just got to put log 5 in the calculator. Alright, and then you should get 6.69990. Okay, and then if you put log 0.3 in the calculator, you get negative 0.5229. Alright. So you just got to put these in calculator. You just got to press the log button, then the number. Alright, for calculators, you usually have to reference a table in your textbook, but love technology. Alright, so now we're going to get those problems where I made a whiff and I scheduled that delta math stuff. So now having common logs, we know how to solve exponential equations where the variable is the exponent. So to solve these, we take the common log. Alright, so step 1, you're going to take log of both sides. Okay, so you're going to get log of 4 to the x is equal to log 19. Alright, now we use our power property. Okay, so that means that this guy is going to drop in front. So we have 4, typo. Get x log 4 is equal to log 19. Now we just got to solve. Alright, and we do that by divide log 4 from both sides. Okay. And we get x equals, so we put this in the calculator, log 19 divided by log 4, and we're going to go 4 decimal places here, so we 2.1240. Alright, so round to 4 decimal places. Okay, I believe that's how chemistry class works it, so we'll do the same. Alright, next one. So we have 2 exponential inequalities where the variable's in the exponent, so this is where you take your common log. Okay, so you get log 3, 5y is less than log 7y minus 2. Alright, so we do our power property. So I'll just drop these guys in front. We have 5y log 3 is less than y minus 2 log 7. Alright, so I'm going to divide. Let's put it over here. So now I just got to solve. It's because these logs are actually numbers, so just treat them like numbers. So divide by log 3. So I get 5y is less than It's 1.7712 y minus 2. All right, so it gets a little ugly. We've got some crazy numbers going on here. So distribute. 5y is less than 1.7712 y minus 3.5424. Subtract 1.7712y. Okay, so 5 minus 1.7712 turns out to be 3.2288. Y is less than negative 3.5424. Divide by 3.2288. We get y is less than negative 1.0971. Alright, so our next part is the change of base formula. And you used to use this before the calculators had software in there. You can just plug the base in like this. So what we do, we have log base a of n, so you just make log n divided by log a. And that's how you would solve these if you have a calculator that doesn't have those capabilities. Alright, so probably most of us right now, let me check my phone, see if it has it on there. Yeah, so if you're using your phone, don't have a graphing calculator, you would have to use this method. Alright, so it's a good thing we have it, because the phones don't have it, unless you download a scientific calculator app. Alright, so we have log base 3 of 20, which means you get log 20 divided by log 3. Alright, so these are our common logs. So then you just plug them in the calculator, and you get 2.7268. That is what log base 3 of 20 is. Alright, word problems, everyone loves them. So the loudness, L in decibels of a sound, is the formula. L is equal to 10 log I over M, where I, let's highlight what we got. So L is decibels, I is the intensity in sound, and M is the minimum intensity detectable by the human ear. So residents living several miles from a concert venue can hear the music at an intensity of 66.6 decibels. How many times the minimum intensity of sound detectable by the human ear was this sound, if M is defined to be 1? Alright, so let's look at what we know. So L is unknown. I is 66.6, and M is 1. So we just got to plug into the formula here. So L is equal to 10 log of 66.6 divided by 1, which is just 66.6. So all you have to do in your calculator is 10 log 66.6. You get 18.2347. That's how many more times the minimum intensity of sound it is. So it's pretty loud. Alright, a word problem, and that concludes 7.6 common logarithms. Stay tuned for next time.